people in the hackathon that have done some Android development, but never made any game development. I'm going to talk about one of the applications that I've developed. And I'm not sure if this is best practice or not, but it's I know it's working, and it's probably hopeful it's a good start for beginners to get into game programming. So I'm not using any advanced features like NVK programming or OpenGL. I just use the basic 2D graphics of Android. And the source code again for this game, Swipe and Roll, and for a similar game called Break In, can be found at these links. So I'm mainly going to talk about the game Swipe and Roll. This is an application I've developed a little bit now and then, and it's open source, but it's not on the Android market yet. But if you want to try it out, you can just Google for Swipe and Roll, and you'll get to the source, and you will also find the APK file that you can install directly on your device. There is currently 6 or 7 levels. So this application uses the accelerometer, the touch screen, and both 2D graphics and 2D physics. So the source code is released under Apache license, and the graphics is made by a friend of mine called Quick Out. I'll show you quickly how the game works. It's a labyrinth game where you use the accelerometer, you tilt the device, like in most labyrinth games on phones. So the goal is to go up to the left, into the goal. So if you go into the hole, then it's game over. And you can also swipe these blue things so that you can find a better way to your goal. So you swipe both of them, and then you come to the goal. Well done. So I'm going to go through how you code this in Android. And these are the parts I'm going to talk about. So there will be a lot of code in this presentation. So those of you who are not coding, you can fall asleep or do something else for a while. Wait for the next presentation. So I'm going to start with describing what a game loop is and 3 different ways of doing that in Android. I'm going to talk about the surface holder and surface view that you would use in the third of these ways, where we also use a separate thread for the graphics. Then a short look at the accelerometer and how you use that one. How we handle interruptions in the phone. This is something special for game development on the phone, that you never know when suddenly the phone rings. You have to take care of that, make sure that the game doesn't crash or make something unexpected. And when the phone call ends, you should be able to continue playing the game. Like when you when the phone call. Then I'm going to talk about 2D graphics and the canvas object. A few words about things you have to think about with the screen size, ratio, and density of devices, since you never know what kind of telephone the user has. Then some words about coordinate systems, touch events, and finally full screen. So these are some of these things are very basic. But it should be enough to get started with game programming. So when you write the game, you typically have a game loop. And Wikipedia describes this like this. you have some while loop or some similar that goes round and round, and for each step you check for user input, run the artificial intelligence of the application, move the enemies if there are any in the game, resolve collisions between the enemies and the main player and the movables. Then you draw the graphics, play the sound, and then you do everything all over again. There's actually one more step yet to check for different states in the application, whether the game has ended or not. If it's game over or if the player has won. So if we look at how this, one way of doing this in Android is to just use the onDraw method to override that in the view. Then you automatically get the canvas object here, and you can call your internal methods to update input, AI, physics, and then you have a separate method to update the graphics and you pass the canvas object to that method, so that you can draw on the canvas. So anything you draw on the canvas will be displayed on the device. Then you can update audio and finally invalidate. Invalidate is part of view. It will make sure that the onDraw method is called again and again each time. So this is the most simple way of doing it, but it's not very efficient. The next thing you can do is to separate everything except the graphics using a handler. A handler is something you can use in Android to receive events and make sure that the method is called each time. So it's very similar to the previous example. You have this runnable object, and you start it off by posting to the handler this object. That will make sure this method is called the first time. So we do everything again except the graphics part because we don't have the canvas object. And finally we call post delayed to make sure the method is called again. But if you want to do it even more efficient, you have to use a separate thread. And this is the same thread you do use in any Java programming. You just extend the thread object, and in the run method, you have this loop where you go round and round. But you still can't update the graphics because you don't have the canvas object here. So in order to solve this, we have to get a surface holder. So the first thing we do is to call the lock canvas method, and then we get the canvas. And after we have locked it, we can use it. We have to first check that it's not null, because it can be null in case of interruptions when the phone rings or the user presses the back button or the home button on the phone. Then we can do everything, including the graphics part. And finally, we unlock the canvas, so that we handle it over to Android to take care of the rest. So where do we get this server holder object? In order to get that, we extend another class called Surface View. And we also implement the interface called Surface Holder Callback. And this so to start with, in the constructor of the class, we just get the holder and add the this object to as a callback. That will make sure that these three methods of the interface gets called automatically. So the first one is surface changed. It's called whenever the size is changed of the view. That doesn't happen very often, typically just once. And in case you have it maximized to the full size, that's the size you get. The second thing that happens is when the holder is created, and this is when we pass it to the thread. And we have to make sure that we only use this surface holder during this interval between surface created and surface destroyed, because this surface holder is something that you can't use all the time. It will get created and destroyed automatically by Android. So as soon as you get the destroy method, you have to make sure that you pause the thread. So this is similar to some other events of the activity. Okay, I'll get to that later. Okay. First look at the accelerometer. The accelerometer is something we need to detect how the user tilts the device. And this is something that you would expect to just call some methods, get to get the tilt angle of the device. It's done a little bit different in Android. To start with, you have to get the sensor manager. This is something you get from any activity, like to do with all the other sensors. So you start by calling the get sensor list with a type accelerometer. That can normally generate a list of sensors. Usually there is only one accelerometer on a phone. I haven't seen any phone with more than one accelerometer so far. So we say this sensor manager because we need to use it later, and we register a listener that I will show on the next slide to make sure that the listener will get events from Android each time the accelerometer value changes. So later when we want to stop the accelerometer listening, we just call the unregistered listener method. So this is the listener we create. So this is the interface sensor event listener, which only has two methods. On accuracy changed. I'm not sure what you would need that for. I don't think it's needed for the accelerometer at least. So then they have on sensor changed, where you get three values. So it's the force in each direction, or actually the acceleration in each direction, x, y, and z. So then we can just add the simple getters this class to receive these values, like we wanted to start with. Okay, so some words about interruptions. Like I said before, this will happen when the phone rings, or the user presses some of the buttons to hold back or close the device. So when we get the on resume, we have to resume the thread, and we also start accelerometer. Then on pause, We do the opposite. We pause the thread and we stop the accelerometer. So here we have two sets of methods. We talked about surface holder. With the callback methods, surface created and surface destroyed, which we have to take care of. We also have these activity methods on resume and on pause. And we want to make sure that the game thread is only running when we both have the application resumed and we have the surface created. So what should we use? Should we use one or the other? The only solution I found is to use both. So in the game thread, we just define an integer called thread suspended. And we make sure as soon as it's above 0, then the thread is suspended. When it reaches 0, then the thread should start running again. Then we can call this pause method several times. Each time this value is incremented. Then we can call resume several times. And as soon as it goes down to 0, then the game starts running again. I'm not sure about the synchronized part. I think it made sense, but it didn't work, so I just wanted to avoid it. If someone knows more about threading, can talk to me later. Okay, so some words about the 2D graphics. There are three packages in iDrawing that you can use for 2D graphics. It's the basic graphics you have in Android Graphics and Android Graphics Global, and it's the OpenGL, which is an implementation of OpenGL ES specification. And the OpenGL is quite difficult to handle because you have to take care of various versions of OpenGL in different devices. So I've only used graphics and graphics global so far. And as soon as you don't do any very complicated games, then you're fine. If you want to do some really complicated game with lots of objects on the screen, a lot of graphic changes, you may want to try OpenGL instead, and possibly even do it in native code. Okay, so when we're drawing on the canvas, we can do this in two ways in Android. Either we can use the methods of the canvas object, old methods like draw circle, or other similar methods to draw boxes and other stuff. Or we can define a separate object, type drawable or one of the subclasses. And then we just call set bounds to position and set the size of the object. And then we call the draw method and we pass the canvas object to the object, and it will draw itself on the canvas.
What's the frequency of the onDraw call? Does it call at a fixed rate, or when some event happens, then they call the onDraw method?
The onDraw is called as often as necessary. So it's there's some maximum limit, but unless if nothing has changed of the view, then it doesn't need to be called. You can also combine these two methods. You first use methods of the canvas object, like if you want to rotate the object. But there are no, I haven't found any other ways to rotate the object. So you first save the state, you rotate it, then you can set the position and draw the object and finally restore to the original state, so that the canvas is not rotated when you draw the other objects. This is I believe it's similar to how you do in OpenGL as well. Okay, so words about screen size, ratio and density. Android devices comes in many flavors. They have big, small, various densities and ratios. If you look at these three examples from the Android documentation, you see that these all have the same width, but we have the different height. So this is something you have to think about when you make a game, to make sure the game fits within the screen and make sure that each player would see the same thing, so you don't get an advantage of having another phone, especially if you do online gaming where people play against each other. So the way I've done it in my applications is to make everything in this ratio 2:3, which is like the middle of the two. And then if someone has a bigger device, you just add a black line at the bottom and at the top, like you see on the TV. And then the opposite, if you have a screen like this, you just scale it down and you get the black line to the left and to the right. This looks a bit weird. There are some digits missing at the bottom. This is a way to visualize that we have different coordinate systems in the games, and also depending on the screen size. Because when we draw things, we deal with pixels. But when we have, for instance, a physics engine, we have everything in the word coordinates. So you measure everything in meters or something similar. So you need some way to translate this. And for the graphics part, we have the origin up to the left. Then the increases to the right and down. Whereas in physics, you usually have the origin in the middle. It increases up and to the right. So in order to solve this, you need some methods to convert between the two coordinate systems. I won't go into any details here now, but you can look at it later if you need it. Okay, touch events are handled by the activity. So you have an on-touch event that gets called as soon as the user touches the screen. So here we want to just return as quickly as possible and just pass this event to the thread, to the game thread, so it can take care of the event. So I added a method to the game thread called add touch event. And this event can be of three different types. It's one event when you first touch it, one when you move your finger, and one event when you release it. Actually, there are several events when you move your finger. So here is one way of handling it in the thread. In the touch event, we first synchronize around the lock object to make sure we don't access these objects at the same time from the main thread and the game thread. Then we get the X and Y values and save them in a separate event. And later, when we call the update input method in the game loop, we can use these local objects. Finally, we set the event to null to make sure that we don't use the same event several times in the game loop. Okay, now to the easiest part, to make the game full screen. Normally, you shouldn't make applications full screen because users expect to at least see the status bar in the top to get access to all the notifications. But in a game, you usually want to have a full screen. So there are two things you need to do. First, to remove the window title. And the second one is to remove the status bar. Okay, so any more questions? Yes? Oh, I don't know. I've never I never ported any application from other platforms, so I'm not sure. You get a t-shirt anyway. Yeah, like I said, also. Okay, any more questions? Yes.
I heard Android has voice recognition.
Yes.
Is it possible to make something on the screen with voice?
Oh, I've never tried the voice recognition. I believe that was added in 2.2, right?
Basically, voice basically interpret to a text.
So the voice detect and the output is text.
Text.
Oh.
Recognition is different.
Okay, but this
It's
is
not
still not
identity.
Yeah, but do you think you can use that in the game? To say different words, like right and left or something like that?
There are few games like Talk. I'm not sure. One cat will be history and just talking Tom. Just record and right there. Maybe it would be good.
There are SMS readers. SMS reader. If you get an SMS, it will read the SMS.
What?
If you get an SMS, it will read the SMS first.
Yeah. Okay, any more questions?
You previously mentioned Android having different screen resolutions. Is there a way to automatically rescale the application, the game, to the full screen? An application made for 240 by 320 into 480 by 800.
Yeah, it can get scaled automatically, and that's another option instead of adding this black bars top, bottom, or left, right, just to scale the game up to the right size. But then you have to think it's a different resolution, and maybe it looks weird.
Yeah.
All the surface will become a little
Graphics become pixelated.
Okay, you can have a t-shirt, and anyone else. I always forget to give a t-shirt. So anyone who asks any questions, there are t-shirts for you here. Okay, any more questions? Oh, just here. Yeah, it's they're all Google Apps documents. So I will post the links to the organizers here, and they will email it to you. Okay, any more questions? Okay, thank you very much. We won't have a break this time, so I guess continue with the next presentation. So we have about 10 or 15 minutes. Okay, so this is an introduction to Box 2D for Android. I only have one question for you. How many have used Box 2D before? Okay, like 5 people. Okay. There are other 2D physics engines too, but Box 2D seems to be the most commonly used in Android, though also on many other platforms. So Box 2D is a 2D physics engine, and I'm going to explain what a physics engine is and when you need one. but just skip through them. But if you compare 3D and 2D, again, this is very basic. In 3D, you have objects like spheres and cubes, blocks, cylinders, whereas in 2D are circles, squares, rectangles, and triangles. So moving on to physics. Physics is needed for simulating something like this, for instance. We have different objects. You can throw them up in the air and they will eventually slow down and then fall down again. They will collide with each other and they will have various responses depending on the velocity and the acceleration of the objects. So let's look at some real-world 2D examples where physics is involved. Here's the classic labyrinth game. I'm going to have